Guys, welcome back. In this video, I'm going to discuss about the sum of Xors problem, the fourth problem, which is held in Starters 142 Codechef on 10th July. So let's continue in this video. So basically, before jumping into the solution, I'll make you understand what the problem statement is about, and then I'll explain how the code is written. So if we read through the problem statement, it says that you are given a grid size of n cross m. N and m are both even, where each cell of the grid has a value 0. So it says that n cross m, n rows and m columns, and both the rows, number of rows and number of columns are even. So minimum value n and m can take is 2, and it will go on 2, 4, 6, 8, and so on. And next statement says that let Ri denote the bitwise XOR of all the element of the ith row, and Ci denote the bitwise XOR of all the element of the ith column. So basically, if we see that if there is a box which has I'll start with two rows, and there are some four columns, and it says that Ri is the, and initially all the grid value of the value is 0, and Ri denotes the bitwise XOR of all the element of the ith row. So which means that R1, like, which is the first, this is the first row, this is the second row. R1 denotes the bitwise XOR of all the elements of the first row, which means if you do the bitwise XOR of all the elements along this row, and that will give you the value of R1. And if you do the bitwise XOR of all the elements in the second row, that will give you the value of R2. And similarly, if you do the bitwise XOR in column wise, like in the first column, it will give the C1, second column, it will give the C2, third column, it will give the C3, fourth column, it will give the C4. So basically, after finding each Ri and Ci, and you need to find the ugliness of the grid, which is defined as summation I equals to 1 to n Ri, and plus summation I equals to 1 to m Ci, which means that basically whatever, how many number of rows are there, get the bitwise XOR of all the rows and add it, and how many number of columns are there, get the bitwise XOR of all the columns and add it. That will give you the ugliness of the grid. It doesn't say that add Ci separately, add Ri separately, nothing like that. See, if you expand this one, it will come out to be as R1 plus R2 plus C1 plus C2 plus C3 plus C4. So addition can be mixed up. So it just says that find the bitwise XOR of the rows and columns in any direction possible, which is all directions are horizontal and vertical. So if I now move on to the next statement, it says that Fk denote the minimum ugliness possible after setting the value of exactly k cells of this grid as 1. So f of k is a function. They define this function as they define the function as ugliness. We got the ugliness of the grid has this one, right? And we need to find, let's see this minimum word minimum afterwards. Let's say Fk denotes the ugliness possible after setting the value of exactly k cells of this grid as 1. So I'll take the same previous example. Let's say I have two rows, and I have one, two, three, four columns, and all of them has a 0. So whenever they are given in general terms, just substitute some number, like let's say f1. F1 denotes the ugliness possible after setting the value of exactly one cell of the grid as 1. So instead of this 0, I'm setting it as 1. Then what will be the ugliness possible? Ugliness is given by bitwise XOR along the row plus bitwise XOR along the column. So if you don't know the XOR how it is done, just remember uh, let me just duplicate this tab. Just remember these four properties of the XORs, and try to place them in your template as well. So in any future problems, it will be helpful for you. So basically, bitwise XOR is calculated as if you do the XOR of XOR with same elements, it will give it as 0. And if you do the XOR any element XOR with 0, it will give it as this element itself. So these two properties is the one we are going to use in this problem. The rest of them will be used in some other problem, but it will be useful if you just remember all five the properties. And so what we can come to know from here, it is XOR of A is 0, which means that if A is occurring even number of times along the row or along the column, it will give the 0. Or if A is occurring odd number of times, here it doesn't say that odd number of times anyway. Our grid is made of fully zeros here, so fully zeros here. So if you made it as anything as one, or any one as one, so just if the A is present odd number of times, why? Because even number of times you will make it as zero, then odd A will be present, and odd number A will be present. And if that is XORed with zero, it will give the A itself. Understood, right? So basically, if we come back to the problem, if I make this XOR as one, and along the row, what will be this R1 XOR 1 XOR 0 will be 1. See, basically, if you can do it, like basically you can do it, like one each one XORs, and then calculate how much it is coming, like that. 1 XOR 0 is 1, and again 1 XOR 0 is 1, and till this it is 1, so 1 XOR 0 is again it is 1. Or you can use the shortcut I told you, like if the A is occurring odd number of times, it is will be A, and A is occurring even number of times, it will be 0. A is occurring odd number of times, it will be A only when the other elements are 0. Okay, so 1 is occurring odd number of times, so it will be 1 along this row. Here it will be 0, and C1 it will be 1, C2 will be 0, 0, 0. So if you add R1 plus C1, threshold will be 0. Then ugliness of f of 1 will come out to be as 2. 1 plus 1, it is 2. So if I keep the f of 2, ugliness possible after setting, let's see the minimum word afterwards. Ugliness possible after setting the value of exactly two cells of the grid as 1. Like I am placing the one more 1 here. So if I do the row wise, R1 is 1, R2 is also 1, but C1 becomes 0. Column wise it is. Why? Because 1 is occurring even number of times, right? Two times 1 is coming. A XOR A is 0. A XOR A is 0. Okay, so basically it goes like this. And what we need to do is K ranging from I equal to 1 to n into m. Basically, they will be giving the number of rows and the number of columns, right? First get the value of n cross m. So in this case, there are two rows and four columns, so max to max, k can go up to 8. So it will, we need to calculate f of 1 plus f of 2 plus f of 3 plus so on till f of 8. Okay, and that's how it goes. And afterwards, if you see the input format, it's a single integer t denoting the number of test cases. And if I come to this minimum ugliness possible, especially in this case they have given the test case t, which is denoting the number of test cases. And each test case is separated by two integers n and m, where n is the number of rows and m is the number of columns. That's what we've seen. And we need to calculate this summation. Each f of I denotes the ugliness of the grid, which is summation Ri plus summation Ci. Okay, so it goes like this. If I come to the problem statement, like how this is done, like 2 cross 2, 2 cross 2. Like in this case, they have hidden the one another cases, which is I will let you know what is the case they have hidden it. So let's say you have. Two row or two column, it doesn't matter, since we are going to add ri plus ci in any order. So let's say we have two column and four rows. And we need to calculate till eight possibilities. Let's say I'm placing this as still one here for f of 1. So for f of 1, it will come out as r1 as 1, r2 as 1. So it will come out to be as f of 1 as 2, right? F of 1 as 2, sorry, f of 1 as 2. And next, for f of 2, I'm going to place two ones. So along the r1 it will become 0, Here anyways all the rest of the elements are 0. It is by default you need to consider. And see, r1 will become 0, r2 is already always obviously 0, but c1 will become 1, c2 will become 1. So if we add ri plus ci, it will again 2. Then f of 3, in f of 3, r2 will become 1, c2 will become 1, again 2. In f of 4, R1 will be 0, R2 will be 0, C1 also will be 0, C2 will be 0. Why 0? 1 is coming even number of times along the either row wise or column wise. Okay. So along in the fifth f of 5 will be as f of 5, R3 will be 1 and C1 will be 1. So 1 plus 1 will be 2. I'm sorry, f of 4 is 0, right? And f of 5 will be 2. F of 6, R1, R2, R3 is 0, but C1 and C2 is 1, 2. F of 7, R4 is 1, C2 is 1, again 2. F of 8, F of 8 is 0. So basically, if you see this thing, if either number of rows or number of columns is 2, then when it is in the fourth occurrence, eighth occurrence, I mean if it is in a multiple of 4, like 9, 10, 11, 12, in the 12th occurrence, f value will be 0 and rest of the value will be 2. So basically how we can now by this and rest of the, see, in the multiple of 4 it will be 0, and in the non multiple of 4 it will be 2. Now you just need to frame a formula to calculate the summation f of 1 to k, f of 1 to k, where k is n into m. So if you see that, if you do n into m, 8 possibilities are coming. So 8 possibilities are coming. In that 8 possibilities, find how many number of 4s are there, which is 8 by 4, 8 by 4, which will come out to be as 2. In 2 times multiple of 4s are coming, so in that time it will be 0, and rest of the cases it will be 2. 8 by 4, rest of the cases it will be 2, multiply it by 2. So finally, see, 4 2, right? How much this is coming? 8 by 4 is 2, 8 minus 2 is 6, 6 to 12. That's how we'll get the answer. That's it. In this case, see, if either rows or columns are 2, then 6 and 2 are there. So 6 2s are 12, 12 possibilities. 12 minus 12 by 4 is 3, 12 minus 3 is 9, 9 into 2 is 18. Got it. 2, 2, 2 are there. 2 into 2, 4, 4 minus 4 by 2 is 2, 2 into 2 is, sorry, 4 minus 4 by 4. Yeah, 4 by 4, not 4 by 2. 4 minus 4 by 4 is 3. 3 into 2 is 6. Yeah, we got it. That's how the basic formula is. Next corner case which they have missed is if the number of rows or column is not 2. If the number of rows or column is not 2, that is also easy. Just try to intuitively think when the number of rows and columns is not 2, try to fill. I am taking a 4 cross 4, 4 cross 4, all are 0, right? All are 0. How will you start filling the ones in f of k? Now the trick comes when it says that minimum ugliness possible. So you will start filling one year, one year, and after reaching this area, one, and in the next case how will you start filling it? You will start filling by one or one like this, or you will be making a square first, and then you will go to the next square. How will you start filling? Think about that, and you will get this answer, I mean plus 4. You just need to do n into m plus 4. And when it is 2, I have already discussed, this is a very simple case. You can do it on your own. Thanks for watching this video. Bye.